In this chapter, we're going to take a closer look at Newton's second law. Now, if you recall, Newton's first law talked about the fact that when an object is in equilibrium, it's going to be either at rest or moving with constant speed. Now, Newton's second law talks about the fact that what if there is a net force on the object? Well, if there is a net force on the object is going to accelerate. Furthermore, the acceleration is proportional to the force. So you double the force on the same object, the acceleration will be doubled. If you triple the force, the acceleration will be tripled. Now, one of the things that always complicates matters is friction. And we need to address that and look at that more closely in this chapter. First of all, friction is a force, and it always opposes motion. There is two kinds of friction: static friction, in other words, when the object is at rest, and sliding friction, when the object is in motion. As you'll see in your reading, static friction is always greater than sliding friction. And that's why it's harder to get an object in motion than to keep it in motion. Friction for solid objects does not depend on the speed of the object. So, for example, if you've got a car, and the friction is going to be the same on the car and the wheels and the road, whether the car travels at 30 miles per hour or 50 miles per hour. Friction is the same, as long as the car is moving in a straight line. However, in fluids, which includes liquids and gases like air, friction does depend on the speed of the object. So if you've ever ridden a bicycle, for example, the air friction, air resistance, is greater the faster you try to ride the bike. Here is another very important concept that's in this chapter, and that is the distinction between mass and weight. First of all, let me say that they are different things, although they're often confused. Mass is a measure of the inertia of the object. It's usually measured in grams or kilograms. The mass of an object is going to be the same any place in the universe. Weight of an object is the force due to gravity, and that's usually measured in pounds or newtons. Now, they are proportional. That is to say that on the Earth, for example, the more massive objects weigh more. They have a greater force due to gravity. However, again, they are not the same. So, for example, the weight of an object depends on where it is. So, on the Earth, an object may weigh 100 pounds. On the Moon, it may weigh 1/3 of that. And if it's far away from any gravitational field, its weight could actually be 0. However, the mass of the object is going to be always the same. It doesn't matter where the object is. So remember now that weight is a force, and just like any force, the units are going to be in either pounds or newtons. Okay, now more about Newton's second law. We said that the acceleration of the object was directly proportional to the force. The acceleration is inversely proportional to the mass. So that means that if you've got the same force on the object, if the mass gets bigger, the acceleration is going to actually get smaller. So if you've got a skateboard, for example, and you put a kitten on the skateboard and you give it a push, the acceleration is going to be greater than if you took an adult and put it on the skateboard and give it a push. The bigger the mass, the smaller the acceleration. So we can put these two concepts together, the fact that the acceleration is directly proportional to the force and inversely proportional to the mass, using this formula, F equals ma, or force equals mass times acceleration. Very famous expression formula for Newton's second law. The units for the force are newtons when the mass of the object is in kilograms and the acceleration here is in meters per second squared. So simplest case is if you've got a mass of 1 kilogram and it accelerates at 1 meter per second squared, then you know that the force on it must be 1 Newton. Now, this explains why all objects fall at the same acceleration regardless of their mass. Because if the mass is greater, then the gravitational force is greater. So the acceleration ends up to be the same. And there's a more extensive explanation of this in the text. One other thing that this Newton's law explains is this concept of terminal velocity and air friction. Terminal velocity means that if you've got a free-falling object, it accelerates for a period of time but then stops accelerating. Now this is assuming that there is air friction, air resistance. If there's no air resistance, then the object just continues to accelerate. But if there is air resistance, then object reaches a terminal velocity. And the terminal velocity is reached when the air friction, remember recalling in the previous slide, we said that the faster an object goes in a fluid like air, the bigger the air friction is. So eventually the object goes fast enough such that the air friction is exactly offsets the weight of the object. And now we're back to an equilibrium situation where the velocity of the object is going to be constant. At that point, it's called a terminal velocity.